Hello, everyone. So our topic is image classification on human facial images based on age. So human facial recognition has grown to be an important topic right now, and this result can be widely used in different fields such as security monitor, artificial intelligence, etc. And the current approach focuses on extract facial features such as nose, eyes, and then do the classification. So we want to implement models we learned in the course, and we want to compare this performance to the popular models right now. So what we did is first we choose ResNet 34 as the baseline model because this is a very popular image processing model since 2015. So we think this should produce good performance as the baseline model. And we create several our own convolutional layer model. Also, we implement other popular models and we compare the performance. For the dataset, we choose UTK dataset as our target dataset. So this dataset includes over 20,000 images, and with ages from 1 year old to 116 years old. So we think this should be a purple dataset.
So we tried several methods to train our model. So first of all, we have ResNet 34 as our baseline model. So this is the popular model that using the ideas of escape connections and residual learning framework, even though it has 34 layers depth. But it's really easy to optimize and taking a balance between the training speed and accuracy. Then we move one step forward and add several layers. So we add a linear layer to correlate the output of ResNet 34 to the age classes, which has 116 classes. And then we add GLU activation layer to add some non-linearity. And then we tried a much deeper version of ResNet model, which is ResNet 50, and that help us to improve our accuracy. Then we tried another competitor of ResNet, which is VGG16, and it uses 16 layers and a small 3x3 receptive field. So it has a much faster training speed and also can capture some detailed patterns from the data.
Results.
Age prediction is almost impossible. So we consider a prediction within the 5 years range of the real age to be successful. We can see that for all models, the valid accuracy of correct prediction is about 30%, and 53% for 5 years range and 86% for 50 years range. We use cross-entropy to calculate the validation loss, and the loss is about 4. From the result table, we can see that the ResNet model performs good but converges slow. VGG model gives similar accuracy, but it is overfitting. The stacking of thinner layers perform excellent and has a highest accuracy for the accurate prediction. The next slide is a more intuitive slide to show the differences of the results of different models.
From the baseline model, we can get a decent accuracy. If we lose up the criteria, we would get even better results. The ResNet 50 model is different than the ResNet 34, but all the validation accuracies are lower. It took more epochs to train. This deeper and more parameters model might easily be overfitting on our dataset, as our image files are not large. Adding linear layers after the ResNet 34, we need similar numbers of epochs to converge, but this model performs better. This would be a result of the linear layers if able to correlate the output of the ResNet 34 to the age classes. Apart from all the ResNet models, the stacking of CNN layers achieves excellent results. The results shows that the pyramid architecture of stacking the CNN layers is more than enough to work with our dataset. Though shallower than the ResNet models, it still suffers less from the overfitting problem. The overall conclusion is that ResNet 34 and 50 are good, but could easily overfit. However, adding additional layers and stacking CNN layers could achieve better accuracy and saving time. And that's all about our project. Thank you.